3.1 Polynomials. Polynomials mean the front of the word says poly, so it means many. So you have different types of polynomials. You have monomials, which are one term, binomials, which are two terms, trinomials, that are three terms, and polynomials, which are four or more terms. These terms are separated by their plus and your minus signs. So you have different definitions or examples of polynomials and some examples that are not polynomials. So remember, you can't have the absolute value of something and make that a polynomial. You can't have an exponent as a variable. You can't have a fraction that has the denominator of a variable in it. You can't have a fraction or a decimal for the exponent on something, and you can't have the square root of something. Okay, so your leading coefficient is your line leader, so to say. It's the coefficient of the first term when written in standard notation or standard form. Okay, so all of these expressions that we're going to be working with, you're going to be putting them into standard form or combining like terms to put them into standard form, and then giving the degree of the polynomial and the leading coefficient. The degree of the polynomial is the number that the variable is, the highest one. Remember, when you're finding that degree, if you have more than one variable, you add those exponents, okay? So we look at example 1a. We are stating the degree and the leading coefficient of x minus 3x squared plus 8 plus x squared minus 2 plus 4x. So we want to combine like terms here. This negative 3x and this x squared are going to be your line leaders because they have the highest exponent there. So we combine them. The negative 3 plus 1 gives us negative 2. Keep the x squared. Then the x and the 4x combine to give us positive 5x. And then the 8 and the minus 2 connect or combine to give us a positive 6. So from here, our leading coefficient is negative 2. And the degree is 2. If we look at B, we have x cubed y cubed minus 6xy to the fourth power plus 2x cubed y minus x cubed y cubed plus 3xy to the fourth power minus 4x squared y. So we want to look for the degree that's the highest. So we have one that's at 6, so that x cubed y cubed, we're going to look at combining that with the other x cubed y cubed, and they actually cancel out. So we're not going to write that down at all. Then look at your other exponents. You have xy to the fourth, which has a degree of 5, and then x cubed y, which has a degree of 4. So we want to put this xy to the fourth first. So from here, we're going to combine the negative 6xy to the fourth with the positive 3xy to the fourth. This is going to give us negative 3xy to the fourth. Then we have that 2x cubed y minus 4x cubed those are not like terms because they don't have the x cubed. So that x cubed y has a greater degree, so that's going to go first. And then lastly, you have that minus 4x squared y. Okay, so your degree here is going to be 5. So your degree is 5, because remember the x is 1, 1 plus 4 gives us 5. Your leading coefficient is that negative 3. If we look at our next set of examples, we are using this table here. You have different names for these polynomials. So we're classifying the expressions with giving the leading coefficient, the degree, the number of terms, and the name. So if we look at example A, we have 2x plus 4x cubed minus 1. So we want to put this in standard notation or standard form. So this is going to become 4x cubed plus 2x minus 1. Okay, so the leading coefficient here is the 4. Your degree on that term is a 3. You have the number of terms, which is 3, and then the name of the polynomial. So we go with the degree here as well as the number of terms. So your degree is 3. There's 3 terms, so it's a trinomial, so it's a cubic trinomial. For B, they give us 4x minus 2x squared plus 2. Again, put this into standard form so that negative 2x squared is going to go first, then the positive 4x, then the 2. So our leading coefficient here is the negative 2. Our degree is a 2. The number of terms is 3. And then the name, look at your degree, look at the number of terms. We have a trinomial here, and the degree is 2. So if we look at that table, we have a quadratic trinomial. If we look at example C, they give us 7x cubed minus 11x plus x squared minus 2. So again, rearrange this to where it's in standard form. So 7x cubed plus x squared minus 11x minus 2. You have the leading coefficient of 7, the degree of 3, the number of terms is 4. So this is a polynomial. So the name of it is a cubic, because of the degree, polynomial. For D, we have negative 18x squared plus x cubed minus 5 plus 3x. Again, put it in standard form. We have x cubed minus 18x squared plus 3x minus 5. So our leading coefficient, we don't have a number in front of that x cubed, so it's going to be an invisible 1. So our leading coefficient is 1. Our degree is 3. The number of terms is 4. So the name is a cubic polynomial. If we go to the next part, we are adding or subtracting and writing these answers in standard form. So there's two ways of doing this. A lot of times you've done this with the horizontal way and just combined like terms. Another way to do this is to set it up vertically to where your like terms are directly underneath each other, so that way you know what you are combining. Remember, when you are subtracting these, you are distributing that negative into the second expression or set of parentheses to go ahead and change those signs on each of those terms. So for example A, we have 3x squared plus 7 plus x plus 14x squared plus 2 plus x squared minus x. So we can rewrite these with this without the parentheses. So x squared plus 7 plus x plus 14x squared plus 2 plus x squared minus x. So start with your highest degree. You have the 3x squared, the 14x squared, and the x squared. So if we add the 3, the 14, and the 1, we are going to get 18x squared. Then we have the x, which cancels out with the negative x. And lastly, we have the 7 and the 2, which is going to give us a positive 9. So our answer for this is 18x squared plus 9. For B, we have negative 3x squared plus 6x minus 11 plus 6x squared plus 16x cubed minus 5. So again, we're just combining like terms because this is addition, so we just drop those parentheses, rewrite without them. The highest degree here that you have is that x cubed, so we're going to have the 16x cubed first. It doesn't combine with another like term. Then we have the negative 3x squared plus 6x squared, which is going to give us a positive 3x squared. Next we have this positive 6x, which doesn't match up with another x, so we're going to just drop that down. And then we have the negative 11 minus 5, which is negative 16. So altogether we have 16x cubed plus 3x squared plus 6x minus 16. For C, we now have a subtraction expression. So we are going to distribute that negative into the second set of parentheses, changing the sign on each of those terms when we rewrite it without parentheses. So we have 1 minus x minus 3x squared minus 2x plus 5. So then start combining your like terms. The negative 3x squared is your highest degree, so that's going to go down first. It doesn't combine with another x squared, so that's why we're just dropping it. The negative x minus 2x is a negative 3x. And then the 1 plus 5 is a positive 6. So we have negative 3x squared minus 3x plus 6. For D, same thing, we have subtraction, so we're distributing that negative into the second set of parentheses, changing the sign on each of those terms to give us 5x cubed plus 12 plus 6x squared minus 15x squared minus 3x plus 2. So now combine your like terms. Your highest degree that you see here is that x cubed, so 5x cubed is going to be written down. Next, you have the x squared, so 6x squared minus 15x squared is going to give us negative 7x squared. Next, we have the negative 3x, which doesn't match up with another x, so we're going to drop that down. And lastly, the 12 plus 2, which is 14. Oh, I'm sorry. This is a 9, not a 7. This is a 9, not a 7. So we have 5x cubed minus 9x squared minus 3x plus 14. If we look at E, we have an addition expression here. So again, just rewrite them without parentheses. So 2x squared minus 3x plus 5 plus x cubed minus 5x squared plus 2x minus 5. So we are combining like terms here. The x cubed gets dropped down. The 2x squared matches with the negative 5x squared, and it's going to give us a negative 3x squared. The negative 3x plus 2x gives us a negative x, and that 5 minus 5 cancels out. So we have x cubed minus 3x squared minus x. For F, we have x cubed minus 5x squared plus 2x minus 5 minus the 2x squared minus 3x plus 5. So distribute that negative. We're going to be left with 3x cubed minus 5x squared plus 2x minus 5 minus 2x squared plus 3x minus 5. So that x cubed doesn't match up with another x cubed. Drop it down. The negative 5x squared minus 2x squared is negative 7x squared. The 2x plus 3x is 5x. And the negative 5 minus 5 is negative 10. So we have x cubed minus 7x squared plus 5x minus 10. If we look at example 4, we now have distribution within this expression. So we have x times 2y minus 3 plus 4x plus 2y minus 3y times x plus minus 1. So we are going to distribute this x, or this 4, and this negative 3y. So this is going to give us 2xy minus 3x plus 4x plus 8y minus 3xy plus 3y. So then start combining your like terms. The 2xy matches with the negative 3xy, so it's going to give us a negative xy. The negative 3x matches with the 4x, this is going to give us a positive x. And then we have an 8y, which matches with the 3y, which is going to give us a positive 11y. So this is negative xy plus x plus 11y. And again, this is standard form because that xy has a degree of 2, the x has a degree of 1, the y has a degree of 1. So after your highest degree term comes your alphabetical order if you have terms that have the same number of degrees. Okay. Finding real zeros where the graph crosses the x-axis. So you're telling how many real solutions each of these graphs have, and is where that line crosses the x-axis. So if we look at example A, this line crosses 1, 2, 3 times, so there's 3 real zeros. For B, it never crosses, so there's none. And then for C, it only crosses once or touches once, so there's 1. And then for D, we cross twice, so there's 2.